Today I would like to talking about the specific gravity of soil. So if we see in the soil mass, commonly is composed of three components in soil mass. The first one is the solid part. It's the solid of the soil. It's the first one. The second one is the liquid part, is the water, and the third one is the air or pore air part in the soil mass. So the definition of the specific gravity is the ratio between the mass of solid, okay, to the mass of the water at the same volume. What does this mean? Or we can say that if we have the GS of the soil or specific gravity of the soil equal to 2.6, that means the weight of the soil, if we compare to the weight of the water, is about 2.6 times. So the benefits of the specific gravity of the soil, we can know about the mineral of the soil inside the soil mass, such as if the soil is the lateritic soil, they have they compose a very heavy mineral. The weight of the GS of the soil is about 2.7. Okay, so the next part I will tell you or discuss how can we determine the specific gravity of the soil. So the first part is the MS, is the dry soil. Dry soil is quite easy to know. Firstly, you just bring your soil and put your soil into the oven. Okay, after you wait for about 24 hours, you can get about the solid part of the soil. And the second one is the volume of the water at the same way, or we can say that it is the volume of the soil. How can we obtain the volume of the soil? How? If you study in the high school, you study about they have the scientist named Archimedes. If you put some of the object into the water, okay, the water will rising up. If you can calculate the volume, okay, you can know the volume of the object that you put into the container of this one. Okay, so the way we use the concept from Archimedes to determine the specific gravity of the soil in the lab. In the lab, we have some of this one we call pycnometer. They have the mark, something like that is the pycnometer. The concept is something like that. Firstly, we fill the water into the pycnometer. After that, we put the soil in the pycnometer. The soil, something like that. The water will rising up to this. Even we know the volume of the water. The volume of the water rising up is the volume of the soil that we put into the pycnometer. Or is if we know the weight of the water, is this one is the weight of the water is the same volume of the soil. Or we go back to some of the definition of specific gravity again. Specific gravity of the soil, we use the GS. It's the ratio of the mass of the unit volume of soil solids to the mass of the same volume of gas-free distilled water at 20 degrees. That means we have to control the temperature up to 20 degrees. That means if we test in our room is about 30 degrees. We have to find some factor and calculate what is specific gravity is about 20 degrees. So how can we done in the lab? The first part, this one is the equation to calculate the specific gravity of soil. The upper part is the W2. The W2 is the weight of density of the bottle and dry soil. and the W1 is the weight density of the bottle. That means if we use the W2 minus the W1, we get the MS. Okay, is the weight of the dry soil. Okay, for the procedure, how can we do it? How can we do it in the lab? Okay, as I mentioned before, firstly you just put the water into the container. This means the weight 4 is the weight of the bottle plus weight of the water is W4. Okay, well, you know the W4 already. After that, you put the soil mass into the pycnometer, something like this. The water will rise up to this level, and you remove the part of this water. Okay, you can obtain the so-called W3. W3 is the weight of bottle plus dry soil plus water at the temperature. Okay, if you use the weight of this W3 minus W2, what's going on? W3 minus W2, you can obtain this. That means you obtain only the weight of the water is the weight of water here. Is the blue one. Yes. Okay, and the next part is the W4 minus W1 is what? Is the change to be the blue one. Is the W4 minus W1 is the weight of water at what? Without soil. If we use the first part here minus with the second part is the weight of water, the whole water without soil divided by this part, you can get the weight of water subscript soil is the weight of water that this one. That means this one is the weight of the water at the same volume of your soil. Okay, again, this one is the weight of the water at the same volume of your soil. So is this one. The WW is the weight of the water at the same volume of the soil. So this one you can use this equation to calculate the specific gravity of the soil. So it's not easy like that because this one, the pycnometer is made by glass. That means it increase the temperature, the volume will be temperature increase. The volume will be increase also. So you need to calibrate. Okay, the calibrate is according to number 4. You have to calibrate. How can we calibrate? We just plot between the weight of the water and the temperature is the weight of bottle plus weight of the water. That means you have changed temperature and you have to plot something like that to get the calibration curve to here and then up to this one is the calibration curve. How can you change the temperature of the flask? Okay, you just put your flask into an ice. Okay, and after that you just measure, you use the thermometer to measure the temperature and get the this curve. When you get this curve, for example, you test at the temperature here, it's, I don't know, maybe about 30 something, you just get this. You can get this one is W for weight of water of the weight of temperature. Okay, so let's make the conclusion of the specific gravity. Again, the lab specific gravity, you have to, this means the weight of dry soil here. The weight of dry soil is the top part. How can you know the weight of the dry soil? Because firstly, when you're adding the soil into the water, yes, add the soil is not dry. So that means how can you obtain this part? You just when you finish everything, finish the test, you just put the flask contain the water and soil and put into the oven. Okay, when you put into the oven about 24 hours, you can obtain the weight of dry soil. You can obtain this first part. Okay, it's the weight of the steel bottle of dry soil and divide by the weight of the bottle. You can get the first part. It's the weight of the bottle with dry soil, and you minus the weight of bottle, you can get weight of dry soil, this part. And the second part is the volume of the water. How can you obtain the volume of the water? You just put the soil into the pygnometer and water is rising up, and you will determine you can calculate the volume of the water by using this equation. You can, after that, you use the first upper part divided by the lower part, you can get the value of specific gravity.